Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, Editor-in-Chief at Automation World, and the question we'll be answering in this episode is how to choose multi-axis electric motion control technology. And joining me to answer this question is Anthony Leo with Norgren, a supplier of industrial pneumatic and electric motion control, sensors, and actuation technologies. So thanks for joining me today, Anthony.
I appreciate it. Thanks for having me on.
So to start here, Anthony, can you explain what's meant by the term multi-axis electric motion control technology, and how does it differ from more general electric motion control and pneumatic motion control technologies?
Yeah, so it's quite simply the ability to combine actuators in a normal single axis into a multi-axis way. So you're doing something within a 3D plane and trying to perform a task within that plane. So whether it's a pick and place, material handling, 3D printing, something along those lines. With General Electric, you have to control and combine multiple motors. Kind of think of like an Etch-a-Sketch where you're kind of turning the knobs in different directions, or two different knobs to kind of go in an X, Y in that example, add a Z to it to go up and down. And that's kind of what you're doing to control and combine those multiple motors now to move one spot within that XYZ plane. And so also with electric, it's easier to have precision control, generally easier to set up than a pneumatic solution, because you don't need all the air infrastructure available. You're going to have a little bit less maintenance than some of the traditional pneumatic solutions, whether with the actuators themselves or with the airlines that need to supply the air coming in. So overall, it's also a much greener technology to perform, a multi-axis solution on.
Thanks for clarifying that. So one question I had, in thinking about these technologies, is multi-axis electric motion control suitable for harsh industrial environments, or is it more suited for production operations with fewer environmental hazards for electronics?
It depends a little bit on the application. So the short answer is it can be. It really depends on the environment and the type of actuator that you do need. So we can add, from our side, for example, different additions to a general actuator to make it clean room safe. Maybe an ATEX certification, do cold room or anti-explosion. There's a lot of different things that we would add on to, say, a traditional actuator to make it suitable for more harsher environments. We've got into some pretty dusty stuff. So maybe with the dusty environments, it might require a little more streamlined design, maybe a cover over some of the components, or maybe a method sometimes where we add some holes on the side for dust or debris to get kind of pushed out instead of kind of caking up in the corners of actuators. So there's definitely opportunities to do that. When you're talking about full wash down for maybe a food application where you need a IP65 or 69K, typically a lot of that can be done with a rod style actuator. So it really just depends on the application itself. It depends on the type of actuator that might be needed to be able to do something maybe in a little bit harsher of an environment.
So it's more, to your point, it's more about the actuator itself, more so than the multi-axis electric motion control technology itself. So there's ways to adapt it, the actual actuation side of it.
Yeah, and usually we go through that process with the customers up front when we're looking at a system. We'll talk through what the conditions are like, what maybe environmental concerns that may come up in those particular applications, and we'll kind of consider that as we're designing the actuators at that point.
And what about weight handling? How does that aspect of an application, figure into the use of multi-axis electric motion control technologies?
It's very important. So we need to understand to size the appropriate actuator and make sure that things are going to work as the customer expects. We need to calculate the moment loads, the inertia calculations that need to be done to appropriately size it. So this obviously, the weight for the application and those calculations will drastically affect the performance and the durability of the product. So again, choosing the right option is very important. And then depending on if it has an offset load, if you're pushing something or pulling something or simply carrying, that all matters in the design aspect of a multi-axis or even a single-axis electric actuator solution. So again, we typically ask the customers for the application data. We generally will do a lot of the calculations for them to size it appropriately, and that way the customer can be certain that the product that they're getting from us is actually going to work for their application, instead of them trying to guess, put something in, and then a few months later figuring out maybe it was an undersized actuator for the application. So it's pretty important and part of the main process that we go through to figure out the right actuator.
Okay, so a pretty key aspect of the selection process around that. Okay.
Absolutely.
Another aspect, I'm wondering about here, when it comes to multi-axis electric motion control, is it better suited for longer distance motion applications or shorter distance applications, or does it matter?
It really doesn't. The answer is all of the above. So we've gone up to some of our longest applications up to 60 meters so far, which is pretty long. I guess technically we could go up to 64, but our factory is 64 meters long, so that's the furthest we can go at this point without cutting holes in the wall. So up until that point, but yeah, so we can go pretty long with the electric, and we can cut those to exact lengths. But we also have some applications where we're moving, maybe 20 millimeters. So it really just depends on what the customer needs, but it's a great solution for no matter how long of a distance you have.
Okay. So any plans to cut holes in the wall to go beyond the 64 meters there?
Not just yet, but if we come to an application that requires it, they may. So
we figure it out. All right.
Yeah.
So, another characteristic, when you're coming to, discussions of motion control technologies, what about the speed characteristics? How does that figure in with multi-axis electric motion control? And again, in comparison with general electric or pneumatic motion control?
Yeah, with electric, for example, on our side, we can accelerate up to 10 Gs. So we can move pretty quick, go very fast. It kind of depends on the guide systems and the drive systems that we might put into that particular actuator to get those performance levels. But they definitely can move very quick. For short movements, pneumatics perform very well. They've been used forever for very short, quick actuation. So there's definitely I think more of the positives or the differentiators between the two when it comes to some of the other things, such as, like I said, the maintenance, the total system cost, reduction of having to have the air and all stuff that generally comes into a little bit more of the consideration. But when it comes to the speed characteristics, it probably depends a little bit on the payload and the distance that you're trying to move on, maybe which one will have a better speed characteristic or performance between electric and pneumatic. But we definitely have some pretty fast applications that require us to move very long distance that electric performs very well on.
And kind of as a follow-on to that question about speed, it's one that kind of comes in conjunction with it most often. That's accuracy. Can you comment on the accuracy of multi-axis electric motion control compared with the other technologies we're speaking about?
Yeah, and this is probably one of the key reasons why people have been looking at replacing pneumatics with electric, especially when they're designing maybe a new system, like an OEM that's building a new system to eventually sell to their end customers. Electric allows for much more precision capabilities than pneumatics. Since you're basically just driving a motor, whether it's a stepper or different type of motor, ours are motor agnostic, so we can pretty much marry up with anything out there. But you're essentially just driving the motor with a PLC or again, a simple stepper. Whereas with pneumatic, there's a lot more effort and time that goes on the setup process to get pneumatic to go to a specific point and dial that in. And then there's much more maintenance on the back end once that system's installed to keep that running properly. If you have a drop in air pressure, you have a seal that starts to wear, the accuracy starts to go away. So that's definitely one of the big reasons for electric compared to pneumatics is the ability to quickly get it exactly where you want it and know that it's going to go back to that same place every single time. Electric is extremely good at that. So again, is depending on the guide and the drive combo, we can even get as much as 0.02 millimeters plus or minus accuracy. So we can get pretty good accuracy on that.
Okay. All right. And what about energy use? Is based on your experience, I guess, with Norgren's own testing as well as what you're seeing at customer sites, is multi-axis electric motion control a good choice for energy efficiency compared to the other options?
Yep, that's also one of the other bigger reasons why people are looking at electric in general. It's much more energy efficient as a technology and as a system. Again, you don't need to worry about air compressors, leaks throughout the system in the facility, air distribution throughout the facility. There is a lot of, especially when you get to some pretty large companies, a lot of costs that comes out, hundreds of thousands of dollars sometimes per year in air leakage that wastes. And of course, if you're running that compressor, it obviously uses a lot more energy. So where you simply have an electric actuator with a motor and you essentially just plug it into the wall, that power usage is right then on demand essentially used instead of trying to supply it somewhere else, pass that through a facility, and then arrive to that particular machine. So it's extremely big as a reason why people are leaning towards this way for a more greener technology. It also, from a system level, can make things a little bit easier when you have a machine that has electric and pneumatic components. If you can get rid of or eliminate a lot of that pneumatic stuff and have pure electric actuation in addition to the other things on that particular machine, now all you got to do is plug it into a wall. And it's also at that point easy to move around the facility if layout plans change or a new machine comes in, we need to move things. You don't have to move all the airlines and stuff. It's as simply as it's just putting a new electric drop potentially. So there's a lot of benefits on that side too, but it's definitely from a system standpoint much greener of a technology than some of the pneumatic counterparts.
And one follow on that, because you're talking about just moving to another place. So I take it take standard voltage. Anything special requirements for this or?
Nope, nothing special.
Okay.
We can use a lot of different voltage requirements depending on it's more so depending on the motor that might be driving it. Mm-hmm. But once we understand that, we can actually supply certain motors as well that we can supply with the actuator. When we get into some of the IP stuff with the rod style, that will come with a motor to make sure we have that IP rating. But generally, once we understand maybe the OEM or the end customer has a certain motor they want to use, we can size the right adapter. We will at that point know the power requirements for that and everything. So it's usually a non-issue. We can use anything pretty much.
Well, thank you again for joining me for this podcast, Anthony. And thanks, of course, to all of our listeners. Please keep watching this space for more installments of Automation World. Get your questions answered. And remember, you can find us online at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.